Welcome to the Insightful Professor. Today we continue our examination of classes in Java. What we're going to be talking about is parameters and arguments, but more specifically we're talking about how we communicate with subroutines or functions or methods through a mechanism called pass by value. So let's get into a little bit of the background, and then we'll explain how classes come into play and the methods and being able to communicate with these methods or subroutines. So we talk about a parameter providing some kind of vehicle or mechanism through which we can communicate from outside of a subroutine, say a function, to within the subroutine or within the function. How do we pass data or information into this routine? That's what a parameter describes. So parameters are part of what we call the interface of the function, and the notion of the interface is something we've discussed in other videos. The idea is the interface identifies for the subroutine the name of the subroutine. What is this method or this function that we're going to be calling? The return type, because it's a function, it would be returning a value. If the subroutine was a procedure, which is something supported in other programming languages, we don't really see that in Java, but just for completeness, I mentioned that there would be no return type if it was a procedure. But in the case of Java, we're communicating through our methods as functions, and functions have a return type. So the return type is also acknowledged in the subroutine header or interface. The parameters are also mentioned here. The parameters indicate what will be communicated to the subroutine. What is the subroutine going to be given as input, and what will it operate on? So the interface does not include or does not specify details of the body of the subroutine. It doesn't say how things are going to be done or what instructions will actually be executed. It only describes the information that needs to be communicated to the subroutine or the function so that the function can operate on the arguments that have been passed to it. So that brings up the term of arguments. Well, when we talk about the parameter kind of describes what is expected when a call is made, kind of telling us if I'm not familiar with how to invoke this routine, here's the name, the return type, and what I need to communicate to this subroutine. But the arguments actually are part of the actual call that's made. So when I decide to actually invoke the subroutine, the idea is the arguments will say these are the actual things that I'm communicating to the subroutine for it to operate on. So arguments are really the values that are provided when a subroutine is invoked. So the next concept then has to answer this question. How are arguments related to parameters when a subroutine is called? And that's a very good question. It's sometimes difficult to understand because there are two mechanisms or two approaches available. One is called pass by value. The other is called pass by reference. Technically, Java uses only pass by value. So let's explain what this is with a little diagram. Let's suppose we've got a subroutine here called power, and that's being invoked here, where we're returning a value from power to this thing called result. So we're passing in index, which has a value of 2, and this thing called value, which has a value of 10.0. You can see the data types are integer and double. So we start off with index having a value of 2, value having this internal value of 10.0. When we pass by value, we are saying, let's invoke this routine called power, and I'm going to give it value, and I'm going to give it index. But I'm not actually giving you direct access to the storage associated with the variable of index or the variable with value. But what is happening is I'm making a copy of what's currently stored within these two areas, and that is what will be then passed on to the subroutine. So it's actually being communicated to the subroutine as kind of copies. So here we have 2, I make a copy of that. So when I get n internally, n is really a value of 2, the same value that index has. However, if I were to manipulate n internally and alter the value of n, I'm altering this copy, not the source from which I obtained that copy. And likewise with x, I've got a value of 10, which is a copy of the value that's in this variable called value. And if I manipulate x, I'm manipulating this copy, not the original. That's the concept of passing by value. Now, why is that important? That's important with Java because everything effectively is passed by value. Java doesn't really use the notion of pass by reference. That's sometimes confusing to folks, as we'll see when we pass objects as arguments. So let's explain how this works. Objects can also be passed to the methods or the subroutines or to the functions as arguments. But remember, what we're passing when we refer to an object is we're not actually giving you the object. We're working with a reference variable. Remember, if I instantiate an object, what I have is a reference variable that contains a reference to, or the pointer to, or the address of that object somewhere in memory. And when I pass an object as an argument, I'm actually using the name of the reference variable and copying its value into something local, just as we saw n and x in the previous example. I'm copying it into something local within that subroutine. Then that subroutine has the exact same value. And what is the value? It's the reference. It's not a copy of the object. It's a copy of the reference or the address or the pointer to where the object resides. So now if I follow that reference or pointer or go to that address, I'm going to the same place as the original source. Okay, think about that for a moment, and we'll illustrate that with some diagrams, and hopefully that'll cement the ideas together. So when an object is passed as an argument, the value of its reference variable is passed. So that's what we're making a copy of, the content of the reference variable, which of course is a reference to or a pointer to where that object resides. So the value of the reference variable, as we've emphasized, is an address or a reference to where that object resides in memory. Notice that we say that a copy of the object is not passed, just a reference to the object, just the pointer, a copy of the pointer. So when a method receives the reference variable, it's possible then for that method to follow that pointer or follow that reference and gain access to the actual object. Here's how it comes together with a little diagram. And there are a couple of examples here, passobject.java and passobject2.java. Take a look at those documents, those source code files for the details. But here I'm focusing on just the key aspect of this communication element. So we've got something called display rectangle, and we're passing this thing called box. Well, what is box? Box is a rectangle object, but technically box is a reference variable that contains the address or a reference to where that rectangle object resides. So inside of box would be an address or pointer, effectively the address of where the instantiated rectangle or object resides. So what we see here, let me do a little bit of emphasis. What we see here is we've got the address that's in box, and if we follow the address, we go to wherever in memory the rectangle object resides. So when I'm passing box to this routine called display rectangle, I am receiving, through the parameter called r, a reference variable, or the contents of a reference variable. R itself is a reference variable. Just like box would have been created as rectangle box, R is created as rectangle R. It can hold a pointer and address. So this address that's currently in box gets copied into the storage that's allocated for R, and now R is also pointing to the same chunk of memory. That's what's pretty interesting about this. So what happens is the same way that this guy is pointing up here, R is also now pointing to the same thing. So when we say r.getLength, we're using R as the reference variable to provide the context to invoke the getLength method, and we're getting the length of this rectangle object. And similarly with r.getWidth, we're getting the width of this rectangle object. So what we've done is, again, pass by value, because we took the value that's in here, and that's what got deposited into R. But it looks like pass by reference because we've got two different things that are now pointing to or referencing the same memory location. But technically, it is pass by value. Think about that, and hopefully that'll make sense to you. Now, on the other side, how do we send data back from a method? In particular, if we've instantiated an object from within a method, how do we communicate that object back to whoever made the call, to the invoking routine? So methods can return objects, or effectively references to the object. So here what we have is this thing called getWidget, and notice it says public static widget getWidget. Widget, in this case, is the return type. But it's not returning an object, because remember, if we instantiate this widget object somewhere, we are actually making a reference variable, and it's through that reference variable that we gain access to the actual object. So this is actually a reference variable that's being returned that points to a widget object somewhere in memory. So somewhere in the code down here, all this neat stuff happens, and we conclude by saying return, and then we say new to instantiate a widget object by invoking the widget constructor. So these things called P and Q would be defined somewhere in this ellipsis here, this dot, dot, dot. Somewhere P and Q are defined and populated. And what we're doing is passing P and Q, respectively, to the widget constructor. And what gets returned by new? The address or a reference. And we are returning that, and that's exactly what we promised to return, a reference to a widget object. To see the complete code and see it in action, take a look at returnObject.java. And that has the details of this method, but you can also fire it up and see it behave. So finally, this is what actually happens. When we invoke the routine, what we have is we've got this widget object that got created, and we are effectively getting the address here, saying we're passing that back, and here's what gets passed back and then returned to some variable up here. And that, in essence, is what happens. So that's the detail of communicating with the methods, but dealing with arguments that are actually objects or references to objects rather than arguments that are primitive data types. Pretty interesting stuff, but it's a little tricky to grasp at first. But if you walk through the examples and think about it, hopefully this will make clear sense to you. So I hope you appreciated the explanation. And if you have any comments to offer, please acknowledge those in the comments section. And once again, thanks for watching.